Hey everyone, welcome to the mid-unit 4 review. Here we're going over sections 3.1, 3.2, and 3.3 in the textbook. So characteristics of quadratic functions, creating equations when given x-intercepts, or maybe the vertex, or maybe the focus and directrix, stuff like that. So let's go ahead and get started. I'm going to do everything on the we do side. You take care of everything on the I do side. Number 1, given a parabola that has x-intercepts at negative 2, 0, 10, 0, and passes through the point 0, negative 30, what's the quadratic equation? So this is in intercept form, so it'd be helpful if you knew your intercept form formula. So it's f of x equals a times x minus p times x minus q. Remember, your p and q are your x-intercepts, so negative 2 is p, and 10 will be q. And so with the third point, I want you to label that as your x and y. And plug everything in, because we need to figure out our a, because we know that f of x is interchangeable with y, so we know our y, we know our x, and we know our p and q. So let's set that up. So in red, I just wrote it, plugging in my p and q. You can skip that step and jump right to the blue step if you need, because all I did on the next step in blue is just plug in the x and y. So I have x plus 2 because it was a negative 2, so x minus negative 2 is x plus 2, and then minus 10 because it's x minus q, so x minus 10. So 0 plus 2 is 2, 0 minus 10 is negative 10, so we have negative 30 equals a times 2 times negative 10, and so that is negative 30 equals, that looks like that's going to be negative 20a when you multiply 2 and negative 10. And so just divide by negative 20. And we're going to get a equals positive 3 over 2 when that simplifies. So if a is 3 over 2, plug that in right there, and you have your equation. So my final answer is f of x equals 3 over 2 times x plus 2 times x minus 10. And that is all for number 1. So number 2, what's the quadratic equation to a parabola that opens up and has a vertex at 5, 4? So we need to write a quadratic function in vertex form. So your vertex form is a times x minus h squared plus k. So the 5 and 4 are your h comma k. All right, so plug in 5 and 4, and so we have f of x equals a times x minus h, so x minus 5 squared plus 4. And so typically we'd have to figure out this value of a, right, to get the equation, just like we did on number 1. But we're not given any other points. All it says is that it opens up. So with it opening up, a can be any positive number. And that's really all there is to say about number 2. As long as a is a positive number, it'll open up. Because remember, if a is negative, it'll open down. But it could be a fraction, it could be 1/2, or it could be, a big number like, I don't know, 40,000. As long as a is positive, it'll open up and have a vertex. And then plugging in the negative 5 plus 4 will make it have a vertex of 5, 4. All right, so that's number 2. Number 3, given a parabola that passes through the vertex 3, 2 and the point 13, 8, what's a quadratic equation in vertex form? So this is just like number 2, except a little bit more specific. So we need to have our equation in vertex form, and we need to plug in our vertex and then our point for x and y. So I wrote down the equation again, the formula, and then I have x and y labeled for 13 and 8, and then h and k labeled for 3 and 2 because that's the vertex. So plug everything in to your formula and solve for the a. So here it is set up with just the vertex plugged in like we did on the last one. And then now I'm plugging in 8 for y and 13 for x. Okay, so what is 13 minus 3? That's 10. What's 10 squared? That's 100. So this says 100a plus 2 equals 8. All right, so we're going to get some ridiculous answer for our a because I have to subtract 2. And so 8 minus 2 equals 6. So 6 equals 100a. So divide both sides by 100. And 6 over 100 simplifies to 3 over 50. So once you have your a value of 3 over 50, plug it into that very first step we did right there. So your final equation will be f of x equals 3 over 50 times x minus 3 squared plus 2. And that's our equation with a vertex of 3, 2 that goes through the point 13, 8. So number 4, write the equation of the graph and where's the focus? What are you given? You're given a directrix and then a parabola. So you're going to have to use your formula of y equals 1 over 4p times x squared, since this is a parabola that opens up or down. All right. Now, the one that you do, that's a sideways parabola. So you'll start things off with your x equals 1 over 4p y squared. Because remember, anything that goes sideways will be x equals. Anything that goes up or down is y equals. So let's get back to this. So I have y equals 1 over 4p times x squared. So I need to figure out that letter p. So remember, your directrix formula is y equals negative p. And then your focus, since I'm asking for it, that formula is 0 comma p, since this is a y equals equation. So our directrix, let's see here, where's the directrix at? This is at 1, 2, 3, 4. So our directrix is y equals 4. So if y equals 4 and y equals negative p, then p must equal negative 4. So I'll state that right here. So if p is negative 4, then my focus is at 0, negative 4, which should make sense because remember the definition of the directrix is that it's the same distance from the directrix to the vertex as it is from the vertex to the focus. So when I go to 1, 2, 3, 4 and put a dot, that's the same distance away. So my equation is just y equals 1 over 4 times p is negative 4 x squared. And so I'm out of room. Where can I write it? I'll write it right here in this little corner. So y equals, what's 4 times negative 4? That's 16, negative 16. So I have negative 1 over 16 and throw an x squared by it, and that is your equation answer. And that is everything for number 4. And here are the other formulas you'll need for the I do one on number 4. Number 5, just use the formula that I wrote up here, the 1/4 p x squared, because it's a y equals 1 But yeah, you're writing the equation of a parabola that has a focus of 0, 6. So 6 is your P, and see how the sign is flipped on the directrix? So two ways to tell that P is 6 there. So anyway, the equation is simply just 1 over 4 times 6 x squared. And so 4 times 6 is 24. So I have y equals 1 over 24 x squared. And that's all there is to that one. So number 6, find the domain and range of this graph. The domain, remember, it's always all real numbers, always. For any quadratic function, always all real numbers. So I'm just going to spell it out, all real numbers. Now, you might see it as negative infinity to positive infinity, or with that all real numbers symbol. But yeah, just remember, domain's always all real numbers. Now range, it's going from this point and up. So only look at the y value. This y value is negative 4. So my range is y is greater than or equal to negative 4. Or you can write it as it's going from negative 4 in a bracket, because it's touching that, and it's going upwards, so to positive infinity. And that's simply the domain and range for number 6. So number 7, what's the domain and range of this quadratic function, 2 times x minus 3x, x minus 3 squared plus 4? So we're not given the graph, so I think the easiest way to see this answer is to actually graph it on your graphing calculator and look at the picture. So here is the graph, and what do I have to say about this? Well, the domain is always all real numbers, just like the last one. So even without looking at the graph, you know it's all real numbers. So negative infinity to positive infinity in parentheses. Now the range, what's the lowest point? It's at positive 4, and then it's going up. So I'm going to say positive 4 in a bracket to infinity in parentheses. All right. Remember, if it was going down, it'd be negative infinity in parentheses and a 4 in a bracket, but it's going up. You could also identify the domain and range from just looking at the equation itself and paying attention to the transformations. Like, I know that this is going to be a vertical stretch by a factor of 2. That doesn't affect the domain and range. It just makes the graph get a little skinnier. But this goes right 3. And again, that would affect the domain if it were restricted. But the domain is always all real numbers. So it's not going to affect the domain. What's the one thing that's going to affect it? This right here. This going up 4. So your quadratic function always starts at x squared. So when it goes up 4, that's going to affect your range. And see how did I say your quadratic function is always going to start at x squared? I meant to say start at 0, 0. So when it goes up 4, that affects the range, because instead of going from 0 to infinity, it's going from 4 to infinity. So that's how you would be able to tell without looking at the graph. But hey, when in doubt, graph it out. That's actually the last problem on the review. So thanks for watching, and good luck on the test. Bye.